Hi guys, this is Mr. Manchester. Hope you had a fun time with your test yesterday. I'm going to work on getting that graded and turn back to you in the next couple of days. But in the meantime, we're going to go ahead and start Chapter 2. So Chapter 2 is on rational expressions. So we're actually going to skip the first section. The first section just talks about rational numbers. Hopefully you remember what the definition of a rational number is. Remember, we said a rational number is any number that can be expressed as a ratio of two integers. As a ratio of two integers. So what we want to talk about today is rational expressions. So what do we mean when we say rational expressions? Well, similarly, still the same root word, still a ratio. But when we talk about rational expressions, we're talking about a ratio of two expressions. So a rational expression could be defined as the quotient or ratio of any two polynomials. So, some basic examples of rational expressions. Certainly any fractional expression that we've dealt with, just any rational number, would be a rational expression. Also, we'll include variables, of course. Maybe we'll have some binomials and monomials mixed together. Maybe we'll have some factorable expressions. We also might get a binomial and a trinomial, or even trinomials over trinomials, all sorts of options. We could have mixed variables like y and x. We might not. Maybe we just have a single variable. Mostly we're going to have single variable, in fact. But any of these would be examples of rational expressions. Okay, and there's one very important feature we need to be watching out for, or a very important possibility we need to watch out for a rational expression. Knowing that we have variables in the denominator, there will be some values of the variable that would cause the denominator to equal 0, but we know that if a fraction has a denominator that is equal to 0, we call that expression undefined. So, any rational expression would be undefined when the denominator is equal to 0. So for any values of the variable that cause the denominator to equal 0, the expression would be undefined. So what we need to look at right now is to talk about how or when a rational expression would be undefined. So we will have a number of examples that are going to ask us to determine when a given expression is undefined. And it's as simple as identifying when does the denominator equal 0. Okay, so anytime we see the directions here of determine when each expression is undefined, we know right away that we just need to figure out when does that denominator equal 0. So we can even kind of make a note here. If we see these directions, this means set the denominator equal to 0. Okay. So, for example, suppose we had an expression like x plus 5 over 2x. There's our expression. That's a rational expression, right? We see it's the ratio of two polynomials. And we want to figure out when is that expression undefined. We know that is undefined when the denominator equals 0. So we'll simply set the denominator equal to 0, and solve from there. How do we solve equations? And I'm sure you all just said it together, right? We'll isolate the variable by performing inverse operations on both sides. If we want to get x by itself, we'll divide by 2. And on the left side, the 2's cancel out. You'll see that x equals 0. So when x equals 0, this expression right here is undefined. Because if we plug in 0, the denominator will be equal to 0, and we won't be able to actually perform that division. This is all we're looking for. When a question asks to determine when an expression is undefined, we simply set the denominator equal to 0 and solve for the variable. Okay, we'll get a couple of examples. See some of the different things that might come up here. Suppose we had a squared minus 1 over 4ab like we did up here. We're just looking at a couple of these examples from above. Here, this expression is defined for any value of any variable that causes the denominator to equal 0. So when we say set the denominator equal to 0 here, we're going to set 4ab equal to 0. So first we might say, oh, it's obvious I need to divide by 4, but then we get ab equals 0. You'll notice this is a times b. If we remember from last week solving quadratic equations, we said any product can only equal 0 if one or more of the factors equals 0. So if this product of a times b is going to be equal to 0, that would require either a equals 0 or b equals 0. So here are the two situations that would cause this initial expression up here to be undefined. And we need to account for both possibilities. So anytime we're asked to determine when an expression is undefined, this is all we're doing. We set the denominator equal to 0 and determine the values of the variable that cause that value to be 0. Let's look at one or two more here, and I'll let you practice for yourself. Suppose we have something like y minus 2 over y squared minus 5y plus 6. Here's our rational expression. We know a rational expression is undefined when the denominator is equal to 0. So we're going to take our denominator and set it equal to 0. And you'll notice right away we have a second degree polynomial, so we know right away what kind of equation is this. Good. Quadratic equation. Second degree equation, quadratic equation. We know if we're solving a quadratic equation, what do I always do first? Right? We make sure it's set equal to 0, which is already done in this case. And then what should I do? I will factor. Remember, all the cool kids factor. And now we're starting to see why we had to spend so much time getting really good at factoring. So once I've got this equal to 0, I can factor this. And we're all looking at this and saying, okay, I think those factors of 6 that add to negative 5, so we'd have y minus 3 times y minus 2. And then the same thing we said over here, by the 0 property of multiplication, we'll set each factor equal to 0. And y equals 3, and y equals 2. So what we're saying here is that this initial expression up here is undefined if y equals 3 or y equals 2. Either of those values for y would cause the initial expression up at the top to equal, or excuse me, to be undefined. So why are we talking about undefined values? The fact is, if y causes the expression to be undefined, we can't do anything with this expression. So we'll see that there are different functions that come up throughout the next few years that have these rational expressions. And whenever there's a rational expression, we have to always make sure we remove any values that cause the expression to be undefined and exclude them from the set of values that we're looking at for this function. So this is our first most important skill for working with rational functions, is we always need to make sure we start by identifying When is the expression undefined?